Okay, I thought I'd make a video of this because I have seen it a number of times. This is a timer out of a Whirlpool dryer. Could be a Kenmore, Roper, Estate, Inglis, a number of different brands that are all made by Whirlpool. And this timer has, you can tell because it has the terminals at an angle on the back. A lot of the other timers, the older ones, have terminals all the way around, but this has terminals on the back, and there are 3 connectors. There's one here for these 4 pins, one here for these 3 pins, and then one that goes onto the motor. And what happens with these dryers usually is they will stop heating. The motor will run, the heat will work intermittently to start out with, and then not work at all on any cycle, and it's because of the contacts and the lever in here. So let me show you what I'm talking about and what my fix is for it. So the first thing to do is to take the screws out of the back. It's hard to do this with the camera and the screwdriver, so I'll just show you. There's one here and there's one up here, so I'll get those out and pick the camera up again and keep going. Okay, got the screws loose, so now you're just going to take the motor off. There's gear on the motor, there's a gear it lines up with in here. There is no timing between them, so don't be worried about getting the motor back in the exact same position, because that's not important. So just set the motor aside, put the whole works over, and take off the cover. And this kind of fell out on me, but it sits on here like this. Has to go in front of this contact, so when it is pressed it can engage those. That one is not the problem, so we'll get him out of the way. They're pretty self-explanatory where they go back, but you might want to take a picture when you're working on it so that you get them back in the same place. The guy that's the problem is this one here, and these are the contacts that are the problem. And you can see how they're kind of a little dirty looking and a little scorched looking. What happens to this thing? First I'm going to take this out. Got to kind of fiddle with it and turn it as you pull, and then this will come out. You can set him aside. This side is never a problem. It's this lever right here. So what happens when the cam comes around, it pushes on this little nub right here, and it makes contact with the first contact, and then if the cycle is such that it calls for heat, it pushes to the point where all 3 contacts make. And you can see by this, it's not even moving these contacts in the back. They're kind of stuck together. Yeah, see, I just got them apart from heat, because this lever has not been pushing these contacts far enough. And if I push this hard enough, it'll break loose, because it's kind of from heat glued to the plastic post back there. This contact should be able to move, and there you go. See, it's now loose because it got so hot that it melted itself to this plastic stop. So this is how they're supposed to really work now that they're free. The first contact is engaged now, and if the lobe of the cam is higher, you can see that there are various heights, then it's going to push all 3 contacts together and move that last contact. And so what it should do is something like this. It engages the first one, then if you're on a higher lobe cam, it'll push hard enough to just lift that second one off the stop. That's what you're looking for to happen. So what happens to this guy is they don't use any lubrication in here, talking about your planned obsolescence. And you can see, if I can get it to focus, there is actually a little groove worn in the nub here. Let's see if I can get her to focus better. See, that shouldn't have a little notch in it. It should be flat all the way across the top of that nub. Like that one is. Okay, so this one is under a lot more stress because it has to push all three of those heavy contacts. And those two contacts that you see that look like they kind of got hot are heater contacts. So they're carrying all the current. So they're thicker metal, there's a lot more load. And so what happens is this little surface of these cams eventually wears a groove. And so when it wears the groove, it doesn't push the lever as far. And since it doesn't push the lever as far, the contact that's made back here gets less and less, to the point where it arcs, it gets hot. It can actually burn the ends off these contacts, and then it's shot. You can't really do anything with it. But I have a fix for this. So let me get ready and I'll show you what it is. You can see this piece is kind of straight, pretty much straight. So what I'm going to do is I'm going to take my hot air station here and I'm going to heat up the back of this lever so that I can cause the front of it to just bend forward a little bit, put a little bit more pressure on those contacts, and we'll know we have it right when we have the right action on here. So let me get that ready and I'll start again. Okay, so here's the lever, here's my heat gun, and what I'm going to do is I'm just going to heat up the back of this lever right along here. Now imagine you could do this with a lighter or a soldering iron too, but you have to be really careful because you just want the heat in a specific spot. This material doesn't melt readily. It's a pretty high temperature stuff. But what I'm doing is I'm just heating the back of this, and then I'll move out of the way and I'll try to bend it forward some, and that's not quite enough yet. That is hot on the fingers. So I think what I'm going to do is I'm going to get my pliers here, because that's a little hot on me fingers when I go to bend it. It takes a little while. I have my hot air station set at 230 degrees. I might need to go a little hotter than that. We'll see. There we go, that's kind of warmed up. I'll just bend this guy a little bit and let it cool. Got a little bit of a bend there. Maybe see a little more than that. Hot fingers, hot fingers. And just let this plastic cool down then. That away. So now we have a little curvature to that. So you can see when the cam presses on this, it's going to cause this lever to push a little more, which is what I'm going for. Just wait till it's cooled. Get this thing to stop. Okay, so I'm going to pause it again and get things together and then see how we did. Okay, so here's the part back in the timer. When you're putting these in, you might have to pull these out of the way a little bit to get this programming wheel to go all the way down in and seat, because these little those little nubs will be in the way. So now I have the timer sitting at a location where it's not pressing the lever at all. And I still have clearance between the first two contacts. So they're not making contact. Okay? And that's what you want to look for. You don't want to bend it so much that even when the timer says it's off, these two contacts are touching each other. So as this rotates around onto that first lobe height, you can see that it has engaged. The first two contacts are making contact, but not the second one. The second one's still sitting against this plastic stop. Now if we go around and continue around, try to get to a lobe that's high. I'll change hands here. Yeah, I'll need to use the knob to do that because it's kind of hard to turn. There, we must be on a high lobe now. Let's get this out of the way. So now I'm on a higher lobe of the cam, and you can see that the lever has pushed the first two sets of contacts together and pushed hard enough to get this last contact off its stop. And so you can see that all three contacts are making good connection with each other, and that's what you're looking for. What happens when this wears to the point where it's no longer making good on this last contact, then you get the no heat problem. So we have a good angle, and so as this turns around, once it gets to the point where it hops off that lobe, it's hard to do this. Here, let's do it that way. It just hopped down onto a lower position. You can see the first two contacts are still engaged, but the last contact has been disconnected. So I keep going around. Now we're back to a heat cycle again, so all three contacts are making. You can see we're coming around to a place where we're going to drop to the first contact only, right there. And then we'll get to a point where it's the end of the cycle, and so this will drop into this lower notch and release all three from each other. So no contacts are made right now. Okay, so we have a good amount of angle there. It's actuating the contacts well, and so what I'm going to do is I have some little burnishing tools for contacts, just a little cardboard thing here. There's some wet or dry paper that I sometimes use, 400 grit, depending on how funky the contacts look and how beat up they look. You might want to use an emery board first that's really rough, and then go to a really fine file, or this is actually a contact burnishing tool for finishing contacts to polish them up. So rather than leave these all black and funky looking like they are, I'm going to clean them up and then go on to the next point. So I'm going to pause here and get in here with my tool like that and just go over all three of these contacts and make sure everything's cleaned up. And then I'm going to show you what I do next. I'm going to lubricate this thing, so hopefully we're not going to get any more wear on that lobe, which in my opinion they should have done that at the factory. They should have lubricated this thing, and then this would never be an issue.